Hello, everyone, and welcome to the senior capstone presentation for Jake Engineering. Jake Engineering consists of John Dauphin, Catherine Hernandez, Aaron McCabe, and Alexis Reynoso. We are all seniors in the civil engineering program, and we have been working on the Sullivan Square multi-use parking structure for the last 2 semesters. So Jake Engineering has been tasked with designing a parking facility for the Sullivan Square MBTA station, which is right off of I-93 in Charlestown, and it's a major bus station as well. Right now, there's only 197 parking spaces, so there's a high demand for increased capacity due to its convenient location at the end of the Orange Line, and also not being too far into the city of Boston. We hope by adding an additional 500 spaces across 3 floors, that we'll be able to reduce the footprint of the amount of passenger vehicles on the road and reduce the congestion and traffic within the city itself as well. The new building will consist of 3 different floors and a green roof and community garden, as well as the Teamsters Union Medical Clinic on the ground floor that is already on the existing lot. The whole facility itself will be approximately 660,000 square feet, and we will have alternatives to traffic control and some sustainable implementations that will help offset the carbon footprint of the garage itself, such as the garden and the electric vehicle charging stations.
The civil site discipline is responsible for gathering data such as zoning regulations, utilities, contours, and parking regulations. This information is provided by Mass DOT, Boston Water and Sewage Commission, and the Charlestown zoning bylaws. Using programs such as AutoCAD Civil 3D and HydroCAD, the design of the proposed building plans were carried out. The site civil engineer is also responsible for designing the overall layout of the site while creating a stormwater management plan, utilizing the best management practices. By implementing a green roof infrastructure along with infiltration basins, we'll be able to rehydrate the subsurface by about 60%.
The geotechnical aspect of this project entails gathering site analysis, followed by the design portion. The soil investigation consisted of gathering data around the area of Charlestown and Somerville. This data included historical information, USGS reports, and soil borings. After the geological research has been achieved and surface deposits are determined, the next step is considering the design process. The design process consisted of determining a foundation, acquiring the correct piles, and calculating the capacities. All loading capacities were done by hand calculations, and an evaluation was used by using GRL Weep software. On the right side, we can see a soil profile underneath the building layout and a pile foundation for a single column.
Right, the traffic engineering aspect of this project included an in-depth analysis of all existing traffic conditions on the site, such as points of interest, traffic flows, number of lanes, intersection signalizations, surrounding public transportation, and more were performed. AIMSUM was utilized to simulate these traffic conditions using traffic count data and census data from Oliver GIS. The 3 transportation alternatives were developed with the goal of improving traffic performance while additionally adapting to the design of the parking garage. These alternatives were coded onto AIMSUM each, and the performance of each alternative was following 10 replications were analyzed. The best design alternative was one that opened a bus-only lane to the public with an additional lane. This included updating signal timing and curb radius.
For the structural engineering aspect of the project, the main goal was to design the superstructure of the garage itself. I was using a lot of codes such as the International Building Code, the Commonwealth of Massachusetts Building Code, and some American Society Civil Engineer regulations to look up the proper loading that would be necessary for the parking garage, and then using that to calculate loads and load paths down to the foundation for the geotechnical engineer to design, and then putting all of that into both Autodesk Revit and Autodesk Robot to check all of the beam and column sizing and make sure that all of the hand calculations came out correctly and create a computational analysis of said project. On the left, you can see a very early rendering of the footprint of the garage and how it's going to span over Beecham Street to join the two lots together.
Jake Engineering would like to thank all the Wentworth Civil Engineering faculty advisors for their time and guiding assistance, every discipline with design advice, especially Professor Anderson, Professor Asava, Professor Yari, Professor Lambrix, and Professor Hadi. Without their time and instruction, group engineers would not have been as well prepared to carry out such a project. Additional thanks goes out to Dr. Ghassan Kakari for his guidance as an external collaborator of the project, as well as Marco Meza for his advice as a guest speaker. Thank you.